You put it in between the it's not or it's right. He was in there. He was fixing the other class. All the stuff was fairly certainly. No, other stuff.
Okay, let's get started with the class. Last class you had recitations, right? So how was it? Was it helpful? Any questions, doubts on the assignment? So I have uploaded a homework also. So this is the, which one is it? This one is the homework, yes. This is the homework, and this is mostly whatever we have talked about up until last class, right? So we have regular expressions, 2 questions from regular expressions, and 2 from context-free grammars. So these are simple things. I've also uploaded the solution to homework 1. Previous year's homework 1. I've uploaded the solution. It says homework 2, but this is homework 1. Oh no, I uploaded the wrong solution. Okay, I'll upload the correct solution. I uploaded solution to homework 2. Oh no. Oh yes, this is homework 1 solution. Okay, so I did the right thing. Okay, so you have homework 1 solutions I have uploaded, so you can check that while you are doing homework 2 or homework 1 of the summer 2017, right? Your midterm is on 18th. We'll have a review session on Friday, right? And also whatever we have talked about, or we will talk about up to Thursday, will be there in the midterm. So on Friday we will devote the entire class for midterm review, and maybe also on Monday. Because Monday we don't have. Monday we have class, right? Yes. Some part of Monday, not the entire part of Monday. So some part of Monday we will talk about midterm. Any doubts, any questions, assignment, homework, or the material? Because we will switch to some other topic now. Yes. Any doubt? Okay. So we'll switch to this topic, semantics, language semantics. So we finished syntax. Yes.
Yes, sir.
Oh, you have a question.
So the homework is due on the same day as the test,
Yes.
so we won't get the graded back before the test.
No.
It's what's on the homework going to be on the test, though.
Yes. So that's why you have example homeworks and the solutions. Okay, so let's talk about semantics. So whatever we have done so far is just the first step of the compiler. So what we can do is we can take some program written in high-level language, C or Java or whatever it might be. Now they have certain tokens defined. Now we know from that description, using C language or Java or whatever, C++, from that description, how to go to tokens. How did we do that? We use regular expressions. We use regular expressions to extract the tokens, and that was the function of a lexer. Now, after we get the tokens, we went to the next step, saying that okay, when you get the tokens, how can we combine tokens and still make sense? That was the function of parser. So what the parser did was it took tokens from the lexer and it showed us a correct way to combine tokens. That's what it showed us. So now after this lexer and parser, whatever we write in some language, the parser and lexer combination can tell us whether we have done it correctly or not, just the writing part. Whether it follows the rules set by the programming language developer. So if I write some code, it will tell me, okay, this is a C code. It follows the syntax. But can I run it? Can I understand what it is doing? Or whatever it is doing, does it even make sense? You don't know. So one step towards running a program and understanding or making sense of a program, one step towards that is a semantics checker. And that is what we'll talk about today, semantics. So semantics means if you write an expression, say C equals A plus B, is it even possible to write that expression? So I will give you some examples where it might not be possible. So let's see this following piece of code. Can I write this line of code? Why not?
Because it was not declared in that.
Why? A is declared in main.
Not in yes.
So who tells me? Huh? Not the brackets. It's the language that tells me. Because in some language this might be totally fine, right? I define a language C Banerjee, right? And there this might be totally fine. But in C that we know this is not fine. Why is it not fine? Because it's not declared. A is nowhere to be seen in the function foo. A is there in main. That's fine. But A is not here. So that is one case where, so this is a, when you use a lexer or a parser, will you catch this error? You won't. The lexer and parser will say, okay, this is fine, everything is fine, this is a C code, right? But this doesn't make sense. There's no such variable A. How can I set it? Who will tell me that? A semantics checker tells me this. This is one example. Another example is, let's say you have another function. And you have a function Will this work?
No.
Why not?
Not quite.
So now he says it won't work because it's different type. So what is happening here? Here you are calling you have declared a variable b, and that is an integer, and you are calling a function foo2. Foo2 returns a character pointer, but inside foo2 you have a character pointer of the same name b. That's the same name. Integer is b and character pointer is b. So here there is no error. B you can allocate malloc and all those things. And here you are also returning a character pointer b, same name, and you have a pointer, character pointer b that can take a string. You do have it. So why not this? Why doesn't this work? So you have a character pointer b. You have declared it there in function foo2, You also have an integer, that's fine. You have an integer which is declared in main. And you have a character pointer b, you are returning b, you are making b equals foo2. So why won't it work? B is also a character pointer. It's an integer, yes, in main, but it's also a character pointer in foo2. But this does not work. Why? In main, it's expecting b to be an integer. Again, who tells me that? C language specifically. Right? I can define another language that is fine here. Right? But in C language, this is not fine. Why? Because in main, b is an integer. In foo2, b might be a character pointer. Fine. So now there is a confusion here. So once b is a character pointer, again b becomes an integer. So when do I choose what? So there is the notion of scoping. So same variable, which means same variable means it has the same name. It's b, same name, right? Same name, variable with the same name gets two different meanings when the scope changes. So now you have some interesting problems that the semantics checker should handle. It should say, which b is this b? If I am executing this line of code, then which b is this one? Is this the integer b of main, or is it the character pointer b of foo2? Which one is it? If you cannot resolve that, then you cannot execute this code. It will be meaningless. This code is syntactically fine. Nobody will give you problems. No parser will give you problems. No lexer will give you problems. But the moment you run a semantics checker, this is wrong. Now, this doesn't mean anything. That's the problem. Because foo2, although it has the same name b, it has a character pointer which is the same name b. But that b is not this b. This b is integer b. So this b cannot take a character pointer as input. Right? So we have to associate a name with a variable. Who does that? It's also a task of semantics checker. So now we see that semantics checker has a lot of tasks. First of all, it checks, okay, first of all, it has to name. It has to name a variable. Given a variable, it has to give a name to it. Then second, once you have associated the name, variables can have, or 3-4 different variables can have the same name. So how do you take a name and find out the exact variable that you want to use? Name resolution. That is another task of semantics checker. So scoping, name resolution, and many other things that we'll talk about. So that is what we'll talk about in semantics checker. And that is the function of the next level of a compiler. So just summarizing what we just said, that a lexical analysis is concerned with how to turn bytes into tokens, but syntax analysis is concerned with specifying valid sequence of tokens. So we talked about context-free grammar, but the semantics is concerned with what that parse tree means. So when you do lexer and a parser, after the parser, the output of a parser is the parse tree, that we saw, right? So what does that parse tree mean? That is the function of a semantics analysis. And what do you mean by what does that parse tree mean? A lot of different things. First of all, scoping, then name resolution, and many more things we'll see later. So how do you define language semantics? It depends. It depends upon what you want to do. So as I said, C puts all these restrictions. But a different language which I develop or you develop might not have those restrictions. Have anybody programmed with Lisp? Have experience with Lisp? Right? 2 or 3 people. What do you use it for? What have you used it for? Yes?
EMAX,
Emacs, robotics programming. Yes, so robotics, at least they use it for robotics programming. It's a terrible language. Very difficult to understand. I have had very hard time with Lisp. Right? So the semantics of Lisp is very different from C. It's very difficult to understand. You can do very weird things in using Lisp. And it's yes.
Scheme is it?
Pardon?
Scheme.
Scheme is similar. I don't know about it.
It's procedural.
Huh?
Yeah, I think it's procedural. Yeah, procedural.
Procedural function. So yes, so the point of that is C, Lisp, they do different things. Whatever is not allowed in C might be allowed in Lisp, right? So it depends on what you want to do when you define the language semantics. What is intuitive to you? So what properties do we want from language semantics definition? That's what we want to answer first of all. So when we define semantics, what are the properties we should have? Different languages have different semantics. But are there certain properties that we want from semantics that makes it easier to work with? Preciseness. Whatever you write in a code should not have two meanings. C equals A plus B means C, A and B have to be of the same type. C has to be declared, A has to be declared, as well as B has to be declared. You have experience with MATLAB, right? In MATLAB, if you write C equals A plus B, will it work? Yes? Will it work? Just randomly, you in a code you write C equals A plus B. It will work. You don't need to declare C, you don't need to declare A or B, right? So that's MATLAB's way. But when you go to C, you have to declare everything, right? So preciseness is one thing. So which means that if you write a particular line of code, then in order to run or in order to make it meaningful, you need to tell me what exact steps I need to follow. MATLAB says don't declare variables is fine. So if I write C equals A plus B, I know semantically this is right. In C, if I write C equals A plus B, I know it is not right. I have to declare C, I have to declare A, I have to declare B. So these are the precise steps I have to follow. And once I do that, C equals A plus B means the same thing everywhere. Right? In MATLAB, it doesn't mean the same thing everywhere. A can be string, B can be an integer. You do A plus B, it will work. Right? Even A can be a string, B can be a string, C will be a string. A can be integer, B can be integer, C will be an integer. Right? So in MATLAB, you don't really have, it can mean different things. So you might say that MATLAB is not precise, but then preciseness depends upon how you perceive a language. For MATLAB, that is precise. C equals A plus B, even if you don't declare C, even if you don't declare A and B, that is still precise. Precise because the plus operation is doing what it is supposed to do. If there are two integers, it's adding two integers. If there are two strings, it's concatenating them. So plus operator does what it's supposed to do. That's what MATLAB is interested in. But in C, that is not enough. In C, you have to declare A is an integer, B is an integer, then only plus will be meaningful. Right? So it depends upon different language. And preciseness is one thing that we need. Yes.
I was going to say, so yeah, precision limits how the speed of communicating in that.
How the what?
If you want it, yeah, you don't want infinite precision, then that limits how efficient you can communicate.
Yes, yes. So that is one important point that he raised. That precision, how easy you can communicate using a language, right? Or how fast you can write a code. That also depends upon precision, how precise you want your code to be. So for example, a C code is much bigger than a MATLAB code, right? But then portability. preciseness has an inverse relationship with portability. If you get less precise, it might be less portable. So for example, you write a code in MATLAB version 2017, it won't work in 2014, or it might not work in 2014. This is a real case that I face. So what I did was I used two computers, one at home and one in the lab. So I have a code that reads certain files, certain Excel files, comma separated CSV files, and the function of that MATLAB code is to put it into an array. So if I write a comma separated CSV file and I put an enter after one line, right, it will convert that entire CSV file into an array, into a matrix, where whenever you hit enter, it's an end of a row. That happens in 2017. But the moment I use it in 2014, it considers the entire file as a single line. So it gives me a row, an array instead of a matrix, right? So now this is not imprecise. The definition of CSV read function is imprecise. That's why it does not work. Which is portable. It's not portable. But if I had written a C code, it will work irrespective of a GCC. Different GCC. If I just rewrite a simple C code to convert a file into a matrix, it will work in any system, in any GCC. Right? So C is more precise. That's why it's more portable. So it depends what you need. What you need from a language, it depends. Do you need speed? Do you need portability? Depends. Then you have to have predictability. Predictability means if you have a C and equals, right? C is an integer and you have equals, then you know that the left hand side all has to be integer. So predictability is needed. Why? Because when you are doing semantics checking or when you are trying to execute a code, you need to be fast. You cannot wait for a long time. So language has to be, language semantics have to be predictable as well. Then it has to be complete. Now what is complete? It's very vague term. Complete means whatever you want to do, you can do with that language. Now it depends upon whatever you want to do, right? So completeness is not really a precise definition of anything. So how do we specify language semantics? How can we specify language semantics? Typically, we can use English specification. That's what C uses. You have a manual, and there in English, you have written the language specifications are written. The language semantics are written like that. So you have that is one way to go English specification. Now we know that English is ambiguous, right? So a person, two people reading the same specification might come up with two different answers, right? Two different understanding. So English specification is not very precise. Another thing you can have is reference implementation. So you have a code. You give some code. It's just an implementation of something. It does something. Doesn't matter what it does, right? So you have a reference implementation, and what you do is you just see, okay, to add two integers, I need to do it like this, so I write it like this. So just copy the reference implementation. That is another way to do things. Have anybody worked with TinyOS or Nested C? Nested C? Okay, it's an old language. So Nested C had that type of reference implementation. Right. So what they did was it was a simple extension to the C language, so that we can program sensors. Right? Sensors have very small microcontrollers. They're very old microcontrollers. So how to program them? Nested C was the way to program them. So what it did was it took the C language and extended it to provide interfaces to a sensor. So what they did was there was no manual, no English specification, but they had some list of codes. Right? They give a lot of code. So you go look at the code. You decide whatever you want to do. Go look at a similar code and just copy the style. That was their semantics. Another way which is more precise is using a formal language. By using some formal language, you define a semantics. Now, what formal language we'll understand a little bit later. We'll talk about that a little bit later. So formal language is more precise, which means two people reading the same formal language will have the same understanding. They won't have a different notion of a particular semantics. So formal language is more precise, but how it is done, we'll see. We'll see a little bit later. So why do we need semantics? We have already talked about this, that many of languages' syntactic constructions need meaning. For example, variables. Variables need meaning, whether it's integer, string, or what can you do with that variable, all these things are needed to be specified. Functions, parameters, type, operators, exceptions, control structures, constants, all these things need certain semantics. Semantics means just syntactically correct writing doesn't work. You have to extract some meaning out of this. Right? So let's first talk about now whenever we have semantics associated with a variable, what is the basic semantic that we think of? Whenever we think of C language and we think of a variable, what is the basic semantic that we need to do whenever we use a variable?
Type.
So type is a part of. So those are all part of declaration. Right? So declaration is the semantics. Type, variable name, those are the components of the semantics. So whenever you have a variable, you have to declare it. So declaration is the most basic semantics that you need to specify for a particular programming language. So declaration. So some constructs must first be introduced by explicit declaration. Right? And often a declaration is associated with a particular name. So you have to have a name to a particular variable. Example is in time. But this is for C. But many times what we have is that if we consider languages such as MATLAB or C++, let's say MATLAB, there are certain things called implicit declarations. Implicit declarations means you don't really explicitly say that this is an integer, but what you do is, let's say you have defined target to be an integer and you had never defined test value. That you can do in MATLAB, right? Or let's say you define test value, but you never define target, what target is. So test value you have defined as integer, test value as 5, right? Now you write this equation. When that particular programming language which allows this, say MATLAB, when it does the semantic checking, what it will understand is that test value is integer, 10 is an integer number, so I assume target to be an integer. Right? So that is an implicit declaration. Target was not even declared, not even a declared variable. So when you write in this equation, you see that the target was not declared. So I have to declare a variable target. And what is its type? Its type is integer. Because test value is integer and 10 is also integer. If test value was float, then what would it have been? Target? Depends on the language. In C, if you declare target to be an integer, then even test value, even if it is float, you take the integer portion and add the 2 up. But in case of MATLAB, if target test value is float, then target will also be float. Right? So depends upon language. All these declarations and all the semantics checking, everything depends upon the language. Now we know that whenever we have names of variables, it's not often the case that every variable has a unique name. We just saw with an example. Multiple variables can have different, multiple variables can have the same name, right? So if we ask the question, what's in a name? That question has a very difficult answer for many different languages. So the first question that we need to ask is, once a name is declared, how long is that declaration valid? So this is the first example that we saw, right? We declared some variable in main, but then we tried to access in foo, we couldn't. So how long is a variable declared? Whenever it is declared, how long is it valid for? Right? That is one of the main questions that we need to ask whenever we are in the declaration component of language semantics. So is it the entire program? It is the entire file, global? What is it? There are many different ways we can do that. So what we can do is, instead of asking that question, we can also ask a different question as to how to map a name to a declaration. How do I map a particular name to a declaration? So that is part of name resolution. Right? So there are two things: scope and name resolution. So scope is the semantics that we need to understand for declaration, and it has two parts: how long a declaration is valid and how do we resolve a name. So let's talk about C scope, and let's take an example. So C scoping uses block level scoping, which means what? Declarations are valid in a block that they are declared. How do you define a block? By using those curly braces, right? So declarations that are not in a block are global unless the static keyword is used, in which case the declaration is valid in that file only. So if you use some other functions, say library functions, you cannot use that declaration. Right? If you use global, then it can be accessed by any function. Any function, whether it's in the file or not, if it's part of the program, it can be accessed. But if you declare it as static, then it can be only accessed by functions written in that file. If you go to a different library function, you cannot access it. Right? So this is C, but then Java uses function level scoping. So inside a particular function, if you declare certain variables, you can access that. But if you go out of a function, you cannot. Right? Yes. So declarations are valid in the function that they are declared. So we will see some examples. So let's say this is our code. What output do you expect? Following C scoping. Pardon?
It won't compile, eventually error.
It will compile, but it will give an error. Why will it be an error?
It's not defined.
The second I is not defined. I mean, it is defined in the same file, in the same function, in main, but different block. Right? So in that particular block, I is not defined. So when you compile using GCC, you get this error. They will say that in function main, line 11, I is undeclared. Right? So if you count, line 11 is that line, which this one. Yes, this one is a line 11, or maybe the line after this. This one. So this I that is declared in this block has the scope, which is outlined by this green line, right? So when you do print I, that is fine, but if the moment you go to a different scope, then it leads to a problem. Now, if you just modify the code like this, then what output do you expect? It will compile just fine. Pardon? Random, you say. So what is the output? The first thing that it will print is 10,000. The first thing it will print is 10,000. Fine. What is the next thing that it will print? Again, depends upon, this time it depends upon compiler. Right? It doesn't depend upon the language. This time it depends upon compiler. For some compilers, what it will do is it will just by default give it 0. Right? In some other compiler, by default it will give you some garbage value. So what output you expect? So if you do this GCC test scope, then it gives you this value. This is already, we have tested this. Then for a different machine, I use different version of GCC, it gives the result totally random, right? So now this depends upon compiler. So you can choose default values, whatever default values you want to give, right? So now we come to resolving a name. So we talked about scoping. Now it's resolving a name. So when we see a name, we need to map that name to a declaration. As we saw in the second example, that B has two different manifesto, two different declarations, right? One is int B and another one is character pointer B. So which declaration do we use for the name B? So that is one important issue that is related to resolving a name. So we do this using a data structure called symbol tables. Now this you'll do in assignment 2 as well. So we have to use a symbol table to declare to map a name to a particular declaration. So symbol table maps names to declaration and attributes. There are two different ways to do this. One is static scoping and another is dynamic scoping. So what is static scoping? Resolution of a name to declaration is done statically. So you just do once, you never change during the program. Now how do you do it? We'll see a little bit later. So in that case, symbol table is created statically. In case of dynamic scoping, resolution of a name is done dynamically at runtime. So the resolution, that means how you associate a particular name to a declaration, might change during the execution of the program, right? So that is dynamic scoping, and symbol table is created dynamically. What does C use? C uses static scoping. So dynamic scoping is not really existing. Like no programming language really does dynamic scoping in its capacity, right? C does not do dynamic scoping. C does static scoping, but we'll talk about dynamic scoping also. So let's take an example of C. Let's say this is our code. Let's say this is our code, right? So now, if we assume static scoping for C, what is the scope of X? Scope of X means, so first let's see what does it mean by scope of X. Scope of X means where can you access X? Where all can you access X? So in this file, if you write X equals 10, right? Where can you write it and it will still be semantically correct? So what is the scope of X? Yes? Global means where all can you write X equals 10?
Anyway, after that one.
After in text line, anywhere you can write, right? Can you write it in a different file and compile it together?
Yes.
You can still do it. It's global. We haven't declared it as static, right? So the scope of index is starting from this line index to the end of this curly brace, right? So the question is, what will be the output? What will you see as an output for this program? So if in order to see an output of this program, in int main we have written X equals 10, right? That is fine semantically because we are still within scope. Then we go inside a block and we say character pointer X is testing and print X. What will be the value of X? So the first thing that it will print should be testing, right, using C scope. Then it calls the function foo. So you go to the function foo, you have a character C equals C, and then you call the function bar. So you come to bar, and here you have another X. X is 100. and then you call the function baz. In baz, you print x. What will be the value of x? Yes?
Should be 10.
Is it 100 or 10 or what is it? What is it?
10. Because if it was just x equals 100 instead of declaring a new one, it would probably keep the value, right?
Yes, but I'll wait for other people to answer. That is okay. So you have an answer. Anybody else has a different answer? So he says x has to be 10.
Well, does it change to bad?
Does it?
Or what's that basketball?
A baz. We are in baz. So let's analyze. So when x was 10, x had a global scope, right? When we were calling foo. When we are calling foo, x had a global scope. So whenever we are calling foo, we went in and we did character c equals c, that has a local scope of function foo. Then we called bar. In bar, that int x equals 100, that particular x is local. That int x equals 100 is a local variable. When we do baz, we haven't declared x there, right? So that int x equals 100, that is in a different scope. Baz is a totally different scope than bar. So if baz is a totally different scope than bar, that int x equals 100 that we used in bar does not apply, right? So whenever you go to baz, that x that you are using in baz is global scope. That is the only x that you can see, right? You cannot see that x that was defined in bar. So when you see global x, then that means that x is 10. So when you print it out now, x will be 10. So you say C10 as the value to print. Now you change x equals 1337. Which x did you change? The global x. So now you resolve that this x is the global x. So you change it to 1337. Now you return back into bar. You have a local x there. That x is 100. Now the moment you return from bar, that scope is gone. Right? That int x equals 100 scope is gone. So now again, your x again becomes the global scope. 1337. It has the value 1337. So if you return from bar and then again print x, you should get 1337. And then you should get the letter C, and that is the end of it. So that is the output you should get. I have shown all these things again, but we won't go through the animation again. So what is the output? The output that you get is first testing, then the value 10, then 1337C. Right? That is what we decided. So everybody understands why you get that output. Yes.
Can you go over again how x goes from 10 to 1337?
Okay, so let's do it again. So whenever you first always, whenever you are doing a C code, you start from int main, right? So you start from int main, you go to x equals 10. Whenever you go to x equals 10, what is which declaration do you resolve this name to? The only declaration available in this scope is that global declaration int x, right? So you make the global x as 10. Now you come to this scope. Inside this scope, you have another x, which is testing. Now this x is different from the global scope x. This x is the local scope x. So in this local scope, x is a string or character pointer, right? And you made x equals testing. So whenever you do print x, this x resolves to the local x. C static scoping. So if it resolves to a local x, then the first thing that you will print is testing. Now you can come out of this scope. The moment you come out of this scope, here if you had written some code, say x equals something, that x will resolve to where? To global x, right? Because this local x that you had declared is in this scope only. Once you come out of this scope, this x is nowhere to be found, right? So now you declare this is global x. So now you go to function foo. Inside foo, still x is global. Now you do character c equals small c, then you go to the bar function. When you go to the bar function, you declare a local x 100. Now whenever if you had written some code x equals something or print x, that x will resort to the local x, won't go to the global x. The moment, yes, any question? Okay. The moment you call the baz function, then you are going out of scope, because there is another curly brace, you see, in baz function. So you are going out of scope. When you are going out of scope, then that means this syntax is not there anymore, right? So what x is there? Only the global x is there, and which has a value 10. So you print x, which is 10, then you change x as 1337. What x do you change? You change the global x, right? Because that is the only x you know.
You're changing that the global value of that function because it's not declared in that function.
Yes. If you had declared some other x, then that would be that local x. So that's how you get the output. Any questions? Any doubts on this one? Okay, if there are no doubts, we will go to dynamic scoping. Now, dynamic scoping is very weird. It's very interesting, very weird. No programming language actually implements dynamic scoping. Yes. So in dynamic scoping, the symbol table is created and updated at runtime. When resolving X, dynamic lookup of the symbol table for the last encounter declaration of X. So whenever you use a symbol table, you have to consider the last encounter declaration, not the global or not the static, just the last. So X could change depending upon how a function is called, right? So for the same function, you are calling the same function, but depending upon where exactly and how you have called it, the X, the meaning of X in that function can change. So that is very weird. When you call a function 2-3 times, you expect that the semantics of that function will always be same. And when we use C, that is what we get. If you are ever using C language, then a function always has a definite semantics of its variable. It never had, the semantics never change, or the name resolution never changes, right? But if you have dynamic scoping, then 3 different types of calling of the same function might result in 3 different resolutions, 3 different declarations, right? So that is weird. Now let's see some examples. So that Lisp allows dynamic scoping, not the full dynamic scoping, but to some extent, and that's why Lisp is very non-intuitive, extremely non-intuitive language. So let's consider C coding, and let's assume that now let's say C has somehow dynamic scoping, somehow. C does not have it, but let's assume that it has. So if it has dynamic scoping, then initially you do X int X. Now whenever you declare a variable, you have to create a symbol table, right? So now we'll see how we use a symbol table in case of dynamic scoping. So what does the symbol table have? The symbol table, whenever it encounters a declaration, it creates an entry into the symbol table. It's just a stack. So in symbol table you have this entry, and it has 3 properties, 3 or 4 properties. The properties are first name, right? which is x, and then the type, which is integer. Yes. So first it has the name, then the type, and then the other thing is the value. What is the value of that particular variable? So when you first write that int x becomes an integer. Then you come to void bar. You say that bar is a function of the type void. Then you have foo. Foo is a function of the type void. And then baz. Baz is also a function of the type void. You go to bar, and now you see that bar is defined, right? Bar has been defined in line 13. So whenever you encounter a function, you also keep track of which line it was defined. Right? Define means you have to define the body of the function, right? The body of the function. So now you go to int main, and you have main where line it's a function which does not take any input, right? And it is declared here. So now you say that okay, x equals 10. So whenever you reach this line x equals 10, you have to see which is x, which one is x, or which declaration do I go to. So if you want to go to a declaration, what you do is you go to the symbol table and you see when was x last declared. So you look at the first entry, which is main. So you go from top up, right? So last in first out. So that's why you use a stack. So last in is main. So you check that no, this is not x. Then baz, then foo, then bar, then x. You found x, right? So x became integer. So what you do is x equals 10. So you update the value of that entry. X equals 10. Then you come to this code, and you have a character pointer x equals testing. So you have a declaration. The moment you have a declaration, you have to have a new entry in the symbol table. So you have a new entry in the symbol table. Right? Since this is a new scope, you identify it as in that way. So an arrow and another entry. So this basically is a different symbol table, but you can use the same symbol table to represent both. But this is actually different scope. That's why we represent it using arrow. So character x, so you know that x is a character pointer, and it also has the value testing. So next time you are accessing x, what you will do is you look into the symbol table and see what is the most recent x. So the most recent x is this character pointer, and it has a value testing. So you print that. So you print x as testing. Yes. Pardon? A lot of languages do. Whoever has dynamic scope. So now when you are going to foo, you are basically getting out of scope. Whenever you get out of scope, whatever variables you have declared in that particular scope, you have to delete. So you delete this one because you went out of scope. So whenever you go out of scope, whatever variables you have declared in that particular scope, just delete. Right. Then you go to the function foo. So foo now has a new declaration. So again you have this arrow, and you say that the C is a character and its value is C. Then you go inside bar. Now will you delete this entry? You won't, because you are still inside this foo function. So you don't delete this entry. Now you go to a bar. This is a different scope. So you again have another arrow, because this is a different scope. So you have an arrow, and here you say that x int 100. You go to bash. Will you delete x? You won't delete x yet because it's in the same function bar. We haven't gotten out of the function bar. So you go to bash, and now this is a new scope. There is no declaration, so no need to give an arrow. Now you are accessing x. What is the rules? What does the rule say? Dynamic scoping. What does that rule say? The rule says that you search the symbol table, find out the latest version. That latest version is 100, x int 100, right? So now this declaration or this access to value x is mapped to a different declaration, x int 100. So now you print 100 instead of printing 10. So you print 100. Then you come x equals 1337. Which one do you change? Pardon? You change the latest one. Whatever you find. So you change this one becomes 1337. Now you get out of scope of bash. Right? You get out of scope of bash, you don't delete anything because nothing was declared. Now you get out of scope of bar. So the moment you get out of scope of bar, you have to delete that entry. Right? So what you do is you delete this entry. Now once you are out of bar, then what happens? Okay, you are there in that bar. So you come back and you want to print. The moment you want to print x, which x do you resolve to? Again you search the symbol table, whichever is there, the latest one. Now this one goes to 10. So yeah, c goes to c and x goes to 10. So you print 10, right? And that is the end. So when you end, you delete everything, and now your symbol table is empty. So what did we get as result? We got testing 100 and 10c. Right? So that is how static scoping and dynamic scoping changes. So see, static scoping, what output did we have? Yes, we had testing 10 1337, and now we are having an output which is testing 100 10c. Totally different output, just using scoping. Right? So different. So that's what the same code has different semantics, and it depends upon how you define the semantics. Right? So if you define C scoping as different semantics, static scoping, then you get one output. Whereas if you have dynamic scoping, you get a totally different output. So that's how semantics changes what a program means. A lexer and parser would have the same results. Yes.
Or isn't that because semantics always going to be associated with memory and how memory?
Always what? Come again?
Isn't semantics always linked to how memory management works?
Not only how memory management, it's also how computation is done. Right? If you have, so here we didn't do any operator, right? X plus, x minus, those plus minus divide we didn't do. So those are computations, and it also can work. So semantics basically controls how a program executes. It's one way of controlling how a program executes. You define different semantics, you'll get different results. Right? So that is dynamic and static scoping. Do you have any questions, or anybody has doubts as to how we arrived at these numbers?
Yes. Explain is that how in dynamic scoping we get 100.
How we, in the dynamic scoping we get 100? Okay. Dynamic scoping is actually simple, easier than static scoping. So what we do here is, whenever we first declare, just follow this method. You have to have a symbol table. So whenever you encounter a declaration, you put a element in the symbol table. In symbol table, what do you have? You have name, you have type, and you have value. Right? So x int no value because we haven't set a value. Then we define a function bar. So you say bar and it doesn't take any argument and it is not yet declared. So you don't have the line number at which it is declared. Then you have foo. Foo, it doesn't take argument, it is declared on line 4. Baz, it doesn't take an argument, it's declared in line 9. Bar now is declared, so you put it in line 13. Then int main, declared in line 17. Now you set x equals 10. The moment you set x equals 10, it has to resolve to certain value. So what is the only x that is in the symbol table? That global x, right? So you change it to 10. Now you come here. Since the scope has changed, you have to have that arrow and put it in a different table. So x is a character star, it has a value testing, you print. The moment you print, it resolves to that particular x, because that is the first x that you encounter. Then you go to function foo. Function foo declares a character pointer. You go to bar. Bar declares x equals 100. Now when you go to baz, you don't delete that entry because you are still not out of scope of bar. So when you go to baz, you do print x. Now what is this x? So what you will do is you consider the symbol table as a stack. You consider the symbol table as a stack and go bottom up. Right? So last in, first out. So what was last in? That x int 100 was last in. So whenever you're searching, the first thing you'll find is x int 100. So the first thing you'll find, that is what you resolve to. That is the method of dynamic scoping. So that value is 100. So that's why when you come to baz and you print, x becomes 100. So in the midterm exam, you should expect some things like this. And I'll give you some code and tell you to find out the result of dynamic scoping, find out the result of static scoping, and so on. Okay, so till now we have done variable name resolution, right? Now what we'll do next is function resolution. So function resolution means you have a declaration of a function and you are calling a function. Now which declaration to use? In C that is not a problem. In C you have only one declaration of a particular function, right? But in C++, you can override a function. So what you can have is you can have multiple definitions of the same function with the same name, right? Foo can have multiple definitions. How do they differ? Their input parameters, right? Different functions will have different input parameters with the same name. So how you call functions, how you define functions, that also depends upon language. And since that depends upon language, when you call a particular function, Which declaration to resolve that function to, that also depends upon language. In C, that is not a problem because you just have one declaration. In C++, you can have multiple names, or no, you can have multiple declarations, multiple function declarations with the same name. Right? Then it becomes a problem. Which function to resolve to? So how to resolve function calls to appropriate function definition? So do we just use names? C just uses names. Or maybe names and return types, names and parameter numbers, and so on. So we can have a lot of different groups, right? So disambiguation rules are often referred to as the function signature. So what is the function signature? In C, function signatures are just names. The name of the function is its signature, right? But in C++, function signatures are names and parameter types. So name, what is the first input, second input, third input, and so on. That becomes the function signature. So how do we resolve a function to a name? Depends upon what is the what function signature we are using. In C, we just use the function name, so it can only have one declaration. If there are two declarations, it throws a compile error, says that function has multiple declarations, doesn't know which one to use, right? In C++, it's fine. You can have multiple declarations because each function has a name and different input parameters. So that is a part of function signature. So let's consider C++ because just looking at C, there is no point because it won't change anything. So let's look at C++. Let's say we have this code, right? And in this code, we have this call, test equals foo. Which function will we call? The first or the second? The first, right? Why? Because that is a unique signature. Foo, no input. And the only signature that matches is that first function. So what will be the value of test? After executing that line of code, what will be the value of x? 10, right? Because function foo has returned 10. Then you have int bar equals foo test. Which function gets called now? Second one, because it has a unique signature. So what will be the value of bar? 20. Right? Because foo has an input test has a value 10. So if we run it, then we get 10, 20. Right? So that is how you resolve function. Now we have to decide assignment semantics. I don't want to start the discussion today. Right? So what we'll do is we'll keep it to here, function resolution, and assignment semantics we'll talk about next one.
What was it?
Yeah, you remember like
Yeah. Okay. Cool. Because I have time because I'm Yeah, you're stuck. All right. We're going to go eat right now. It's already there. I'm gonna see the I think once it snaps in, like once we figure out what to do, I'm going to the office hours. The office hours on the website as well, because I went there on Friday. So they're well, I figured more stuff out after I read the code. And like, no, I'm in. Oh, you're talking about. Okay, you guys are 355. Oh, you are. Okay. Oh, okay. That's good to know for fall.
Yeah.
But there'll be there's no tutors for that. I think someone told me there's no tutors period for section. Yeah, so there's a lot of screwed in general, whatever. Yeah, well, that's great. Yeah, I heard someone told me that. I was able to use. It's probably what you. Well, because every time I hear people ask for questions with lots of high-level questions there, they usually say they don't officially got someone, but it's like sometimes they do help because they kind of know, they kind of figure it out. Huh? Yeah, the tuning does. Oh yeah. Okay.
But it's not in 60.
Oh yeah, not in the summer. They definitely don't have it in summer. Yeah. They only have like a few people. So we're going?
Not in summer.
Well, see you guys.
I don't know, like like think through it.
Are you going to the
You know, sit down here and just like talk on like questions, like think about the questions. I have time. You have time? Okay, let's see. Like
zero. Because the zero is.
It's fine. Interesting. Yeah, I have like 20 minutes.
Are you leaving?
No, I'll stay here for now. You stay here.
This isn't.
It's about this.
Sure.
I honestly don't know how to start 4 and 5. At least for 1 it's like, I think so, I know I'm going to write something. But for 4 and 5, I completely don't know what I'm asking.
It's a 0. And it's a. Should be getting this.
Class is like discrete math, the next level. It's like,
So that's 0. So I know it's stuck on whatever character gets up to the whole.
This one, what is it asking?
Get char and done.
I'm going to say I don't know for this one.
But it doesn't seem
So
like
I'm
it
gonna
can you.
This is definitely I don't know really.
Have you introduced between the DFA and the I don't know how to get the DFA. There is anything that you can tune on to say.
Okay, basically a DFA is that every, okay, so it's like, take for example this, right? This is the a string which has 0, 1 and 2.
Oh, except for
So if it's okay, draw it up.
Professor, I believe, and I don't know if you have an answer for the 330 tutors, but would you also happen to know anyone for 340?